Look at this. The rhythmic hum of a million circuits. The rivers of light flowing through concrete canyons. This is our world. A complex, interconnected machine of steel, glass, and information. We've built it in what feels like the blink of an eye, a few short centuries of industrial fever. We scar the land with our minds. We reshape the sky with our emissions. We leave our indelible mark on every corner of the globe. We look at this creation, this testament to our own ingenuity, and we are certain. We are certain of its permanence. We are certain that we are the first to have ever achieved it. This belief is fundamental to our identity. We are the planet's first and only technological species. The story we tell ourselves is a simple, linear ascent. From the primordial ooze to simple life to the dinosaurs to the mammals and finally, inevitably, to us. We are the pinnacle. When we look to the past, we see only wilderness, punctuated by the simple tools of our own primitive ancestors. This narrative is comforting. It places us at the very end of a long, dark hallway, the only ones to finally discover the light switch. We are the planet's consciousness, awakened at last. But what if that story is not just incomplete, but fundamentally wrong? Let's erase the city. Erase all of it. Imagine, for a moment, standing on a desolate, windswept shore 1 billion years ago. The continents themselves are alien, unfamiliar shapes. The very air you breathe is thin and strange, with only a fraction of the oxygen we depend on. The sun feels different. The only sounds are the hiss of primal waves on barren sand and the scouring of the wind. This is Earth. But it is a profoundly different world, separated from our own by an ocean of time so vast it renders our imagination powerless. Our minds are simply not built for this scale. We think of ancient as the Roman Colosseum, a mere 2,000 years old. We stretch and we can perhaps comprehend the 5,000-year-old pyramids. A historian deals in centuries, a paleontologist in tens of millions of years. But the Earth itself, it ticks in a different rhythm entirely. Our planet is 4.5 billion years old. That is a number so large it ceases to be a quantity and becomes an abstraction. 1 billion years is not just a long time ago. It is a different eternity. It is a timescale on which mountains are born, die, and are forgotten. This unimaginable immensity creates what we might call a temporal blind spot. Our entire recorded history, from the first cuneiform tablet to the glowing screen you are watching this on, would be a layer of rock thinner than a single sheet of paper in the Grand Canyon of geological time. We are a sliver, a momentary flash in an incomprehensibly vast darkness. And yet, we assume that if another industrial civilization had existed, we would know. We would have found their cities, their monuments, their tools, their machines. We look for ruins. We scan the past for something that looks like us. But here is the central, devastating problem. After 1 billion years, there are no ruins left to find. Let's be perfectly clear. What will remain of London or Tokyo or New York in just 100 million years? The answer is nothing. Not a single skyscraper. Not one. The relentless march of plate tectonics will have crumpled, subducted, and melted the very bedrock they stand on. Countless ice ages will have scraped the continents clean, grinding steel and concrete to fine dust. Erosion will have washed every last particle into an ocean that no longer exists. 1 billion years doesn't just bury a civilization. It erases it from the physical record. So the question changes. If we can't look for a fossilized factory, what can we look for? If a civilization rose, industrialized, and fell in that alien Proterozoic world, what would be left? Would we even recognize the evidence if we found it? What if we've been searching for the wrong things entirely? What if the evidence isn't a thing at all but a scar? A subtle, chemical echo, buried deep in a layer of ancient rock. A faint, anomalous signal that geologists have already seen, catalogued, and dismissed as a natural curiosity, because they couldn't possibly imagine what it truly meant. This isn't just a wild fantasy. It's a profound and perhaps unsettling question about our own place in the universe. It's a hypothesis that forces us to confront our own perceived permanence, or lack thereof. What if we are not the first? What if we're just the latest in a long, forgotten cycle of creation and oblivion of intelligence rising and then vanishing back into the rock? What if we're simply the latest chapter in a planetary story far older and stranger than we ever dared to believe? This is the story of the search for a ghost in time. The first instinct when we hunt for a lost civilization is to look for a lost city. We imagine ourselves as explorers, machete in hand, cutting through vines to reveal a crumbling temple or the foundation of a forgotten metropolis. We are looking for artifacts, a broken pot, a strange tool, a fossilized bone. This is how we find our past. But this instinct, this reliance on physical evidence, is the very thing that blinds us when dealing with deep time. When your timeline isn't thousands of years but billions, the rules of the game change completely. The problem isn't just finding a needle in a haystack. The problem is that the haystack, the needle, and the entire farm they sat on have been systematically obliterated. Our planet is not a passive archive. It is not a museum that carefully preserves its own history. The Earth is a relentless, violent recycling machine. Its memory is written in rock, but the rock itself is in a constant state of being created, crushed, melted, and reborn. And its primary agent of erasure is time itself. Think of the very ground beneath your feet. It feels solid, permanent. It is not. The planet's surface is fractured into massive tectonic plates, and they are in constant, slow-motion motion. They drift, they collide, and in a process called subduction, one plate is often forced under another, diving deep into the Earth's mantle. Here, it is melted, its history erased in a bath of molten rock. 1 billion years is enough time for this process to happen over and over and over. The entire continent that an ancient civilization might have called home is almost certainly gone, recycled back into magma. And what subduction doesn't get, the surface does. Any structure that managed to survive this continental churning would face a second enemy: erosion. For 1 billion years, rain has fallen, rivers have carved canyons, and wind has scoured the land. Mountains themselves, the most permanent things we can imagine, are ground down to mere sand in this time frame. Then there are the ice ages. Mile-high glaciers, acting like planetary-scale sandpaper, have repeatedly scraped the surfaces of the continents clean, pulverizing everything in their path. Steel, concrete, plastic, bone. It all becomes dust. So what is actually left from that time? What is the surface we're supposed to search? It's not on the surface at all. The ground, from 1 billion years ago, is now a layer of rock, a geological stratum, buried under miles of subsequent time. Geologists have to drill deep core samples just to touch it. This ancient rock is the only artifact that remains. A skyscraper, a statue, a library. All would be compressed into a thin, chemically altered layer of sediment, indistinguishable from any other natural deposit. The physical evidence is not just buried. It is gone. This means we have been looking for the wrong thing. You cannot find a fossilized factory. But what about the fossilized pollution from that factory? What if a civilization's footprint isn't a thing at all, but a trace? A sudden, inexplicable change in the planet's chemistry, trapped forever in that ancient layer of rock. A scar. A chemical signature so strange it could only have been produced by one thing. Not by nature, but by intelligence. By an industrial-scale process. This is the core idea of what has been named the Silurian hypothesis. Coined by scientists Adam Frank and Gavin Schmidt, it proposes that the only way to find a long-extinct industrial civilization is to stop looking for their bodies and their buildings, and start looking for their ghost. It's a form of geochemical forensics. We must scan the Earth's geological record not for ruins, but for the chemical fingerprints of industry itself. To find them, we first have to understand the fingerprint we are leaving right now. And that is where the search truly begins. So, how do you hunt a ghost? How do you find a presence that has been physically erased from the world? The search begins not in the remote past, but in the immediate present. The key to finding their industrial footprint is to first, fully, and terrifyingly understand ours. We must study the only blueprint we have for a species that has fundamentally altered the chemistry of its own planet. That species is us. We stop thinking like archaeologists looking for pottery, and we start thinking like forensic geochemists looking for a poison. And the crime scene we're studying is the entire planet right now. What is our single most profound planetary scale signature? It's the very air we breathe. Our entire industrial civilization is powered by setting fire to the past. We are systematically burning fossil fuels, the compressed remains of ancient forests and plankton, locked away for hundreds of millions of years. We are releasing this ancient carbon back into the atmosphere at a rate that is geologically instantaneous. This doesn't just raise the amount of carbon dioxide in the sky. It fundamentally changes its chemical flavor, or what scientists call its isotopic signature. This signature is being written, right now, into the ice cores and ocean sediments that will one day become rock. This gives us our first and most important clue: the Great Carbon Anomaly. Any ancient industrial civilization, if it followed a similar path, would have likely needed to burn its own fossil fuels. This act would leave an identical scar. So we scan the ancient rock layers. We look for a sudden, massive, and rapid spike in light carbon, the signature of burned organic matter. We'd look for a moment in time when the planet's carbon cycle was violently hijacked. And, alongside this, we'd look for the consequences. Evidence of sudden, extreme global warming and a rapid acidification of the ancient oceans. But our fingerprint isn't just carbon. We are master chemists. We invent molecules that nature never imagined. Think of plastics. These persistent, complex polymers are now being deposited in sediment layers across the globe. They will eventually be buried, compressed, and fossilized. We are creating a future layer of rock that will be filled with technofossils. These synthetic molecules are so complex, so unnatural, they would be an immediate smoking gun for any future geologist. So we must ask, are there any cryptic, unexplainable layers in the ancient rock? Layers of complex organic molecules that just shouldn't be there? Then, there is the most unambiguous signature of all. The one that truly separates intelligence from nature. In 1945, we split the atom. In doing so, we created and scattered rare, man-made isotopes across the entire surface of the globe. Elements like plutonium-244, which has a half-life of 80 million years, or curium-247, with a half-life of 15 million years. These isotopes do not occur in any significant amount naturally. A future geologist could date the Anthropocene, the age of humans, with shocking precision by finding this layer. The discovery of a similar isotopic anomaly, a spike in rare transuranic elements in a billion-year-old rock, would be definitive. It would be proof. Finally, there is the collateral damage. Our industrial-scale agriculture depends on nitrogen fertilizers. The runoff from our farms pours into the rivers and then the oceans, creating massive algae blooms. These blooms die, sink, and decompose, using up all the oxygen in the water. This creates vast oceanic anoxic events, or dead zones. These dead zones leave their own signature in the form of widespread layers of black carbon-rich shale. Geologists have seen many such anoxic events in the past and have always assumed a natural cause, like volcanic activity. But the Silurian hypothesis forces us to ask, what if some of them weren't? So our fingerprint is complete. It's a four-part signature. A sudden carbon isotope spike, signaling mass-scale energy consumption. A layer of synthetic technofossils, signaling advanced chemistry. A nuclear echo, signaling the mastery of the atom. And a dead zone sediment layer, signaling the global consequences of industrial-scale activity. This is the forensic kit. This is the ghost we are hunting for in the geological record. We are no longer looking for a city. We are looking for this precise chemical signature of impact. Now, armed with this checklist, we can finally go hunting in the deep past. So now we have it, our forensic checklist, a precise four-part chemical fingerprint of an industrial civilization. Armed with this new tool, we can finally begin the hunt. We are no longer looking for cities, we are looking for this specific chemical echo. But where do we even point our instruments? We must go to the oldest, most stable parts of our planet. Places like the ancient continental shields of Canada Australia, and South Africa. Here, the rock layers from our target period are preserved, like a library of ancient history, waiting to be read. Geologists drill deep, extracting cylinders of rock core samples that are, in effect, books written in the language of time. Our investigation takes us to a specific chapter in Earth's history, the Proterozoic Eon. More specifically, to a period within it known to geologists as the Boring Billion. This era, lasting from roughly 1.8 to 0.8 billion years ago, earned its dull nickname for a simple reason. From a biological perspective, life had hit a plateau. For 1,000 million years, the evolutionary story seems to have been stuck. There were no animals, no plants, no predators or prey. The world was ruled by vast, slimy mats of microbes and algae. It was the planet's long, quiet afternoon. But this boring backdrop is precisely what makes it the perfect place to look for an anomaly. Against a backdrop of such profound, millennial quiet, any loud noise in the geological data should be impossible to miss. In a world of only microbes, an industrial civilization's footprint would not be a subtle signal. It would be a deafening, planet-altering roar. The stage was empty, the ecosystem simple. It provides the perfect, clean laboratory to look for a chemical signature that simply does not belong. Or so we thought. So, scientists take our 21st century chemical fingerprint, and they scan the data from these boring rock cores. And this is where the story takes a fascinating turn. The Boring Billion wasn't so boring after all. Far from being a quiet, stable era, it was punctuated by bizarre, dramatic, and often violent global-scale events. The rock record shows sudden, baffling changes in climate. It shows the oceans repeatedly and inexplicably turning toxic. For decades, we have cataloged these as natural anomalies, puzzles to be solved, but puzzles of a natural origin. But now, we look at them through this new, unsettling lens. Let's take our first clue. The massive carbon isotope spike, the signature of burning fossil fuels. Geologists scanning these ancient rocks find exactly that. They find multiple, sudden, and enormous shifts in the global carbon cycle. Events like the Shunga anomaly, a massive deposit of carbon-rich rock that signals a profound disturbance. The conventional explanations are complex, involving perhaps a massive, unexplained bloom and burial of single-celled life, or tectonic events that released ancient carbon. But the scale and the suddenness, they are a puzzle. Then, let's take our other clue. The dead zones, the layers of black shale indicating the oceans lost their oxygen. The rock record from this time is filled with these oceanic anoxic events. Time and time again, the data shows the planet's oceans were suddenly and catastrophically suffocated. We have always assumed this was due to slow climatic shifts or a change in ocean circulation. We created natural models to explain them, but they remain deeply mysterious. Because the cause we are certain of in our own time, industrial and agricultural runoff, was, of course, considered impossible. This is the heart of the investigation. We take a real geological anomaly from this period. We look at the data. The climate is whipsawing, the carbon cycle is going haywire, the oceans are turning toxic. On one hand, we have the natural explanation. It's plausible, but it's often convoluted, requiring a complex and perfect storm of tectonic, solar, and microbial factors all happening at once. But then, we lay our industrial fingerprint over the exact same data. The carbon spike, industrial emissions, the ocean anoxia, industrial-scale runoff, the climate chaos, rapid, self-inflicted global warming. The data, chillingly, fits both narratives. One is natural, slow, and mindless. The other is artificial, rapid, and intelligent. We must be absolutely clear. The default scientific assumption is, and must be, the natural one. That remains, by far, the most likely explanation. But the Silurian hypothesis gives us a new and profoundly disturbing lens. It forces us to reevaluate these ancient catastrophes. What if we are not the first to have triggered them? What if we're just seeing the faint chemical echo of a predecessor who made the exact same mistakes we are making today? And this is the moment, the point where our tantalizing, chemically driven hypothesis crashes head to wall into the coldest, hardest of sciences, biology. The chemical data, those strange anomalies in the rock, they whisper of a possibility. But the fossil record, the history of life itself, screams an objection. It is one thing to have the fingerprint of a civilization, but you also need a suspect. You need the biological engine capable of building one. And 1 billion years ago, the overwhelming evidence says that engine simply did not exist. Let's be clear about what an industrial civilization actually requires. It's not just a spark of intelligence. It is a physical platform. It needs complex, multicellular animals. It requires organisms with specialized limbs, hands, tentacles, or some manipulator capable of grasping, building, and refining. It requires complex sensory organs, eyes, ears, to observe the universe, and highly developed brains to model it, to understand its laws, to ask what if. It needs bodies that can move, navigate, and radically alter their physical environment. In short, it needs a biological toolkit that took evolution on our planet hundreds of millions of years of brutal trial and error to forge. And even with that perfect biological toolkit, you need one more thing. A catalyst. The single discovery that separates thinking from building. You need fire. Fire is the great accelerator. It smelts metal from rock, it powers engines, it cooks food, it clears land, it forges tools. It is the foundation of all industry. But fire itself has a non-negotiable requirement. It cannot exist in any meaningful, controllable way without a high-concentration oxygen atmosphere. Our own atmosphere at 21% oxygen is a bonfire. But the atmosphere of the Proterozoic? It was a different world entirely. So what was life actually like 1 billion years ago? What does the fossil record, the actual evidence, tell us? The story is unambiguous. The most complex life forms on Earth were simple eukaryotes, the microscopic ancestors of amoebas and fungi. The dominant life on the planet, the kings of this world, consisted of vast, slimy mats of bacteria and algae. These are called stromatolites, and they were profoundly important. They were the very organisms slowly, patiently, producing the planet's first oxygen. But they were, for all intents and purposes, pond scum. There were no animals. There were no plants. There were no brains, no hands, no nerves. And that oxygen they were producing, it wasn't building up in the air. For billions of years, it was instantly captured by the iron-rich oceans, creating the banded iron formations that are now our primary source of steel. The atmosphere's oxygen level at the time is estimated to have been as low as 1%, perhaps even less. In such an environment, you couldn't light a match, let alone forge a civilization. The very chemistry of the planet forbade the existence of fire-based industry. This is the great biological hurdle. This is the wall. It seems insurmountable. This evidence is not speculative. It is the bedrock of paleontology. And it presents our hypothesis with a fatal two-part challenge. First, the planet lacked the fundamental chemical conditions for fire and the high-energy metabolism that complex life requires. Second, and more importantly, it lacked the biologists. The who. The evolutionary timeline is clear. The raw materials for intelligence just weren't there. The factory had no workers. The stage, despite the strange chemical signals, was biologically empty. The case, it would seem, is closed. Unless the very completeness of this biological absence is itself part of the puzzle. What if our assumption that our path of evolution, slow, steady, multicellular oxygen breathing, is the only path? What if a completely different biology, one that left no fossils we recognize, emerged, achieved intelligence, and then vanished? What if that civilization, perhaps seeing the consequences of its own industrial activity, was so completely and totally annihilated that it left not a single recognizable fossil trace? A complete biological reset, scouring the planet of every trace of its existence, leaving only the microbes to start again. This is, by any scientific measure, an extraordinary and wildly speculative leap. It borders on science fiction. It requires us to believe in a form of life we cannot even imagine, one that left no shadow in the fossil record. It requires us to believe in a catastrophe so total that it reset the entire evolutionary clock of the planet. It is the thinnest of chances, a ghost of a possibility. But as we stand here today in our civilization, looking at the very real chemical scars we are leaving, the stakes are simply too high not to ask the question. In the end, our hunt for a billion-year-old ghost leads us to a stark, and perhaps lonely, conclusion. When we weigh the tantalizing chemical anomalies against the crushing, unambiguous evidence of the fossil record, the verdict is clear. The biological hurdles, the lack of oxygen for fire, the absence of any complex life. These are not small details. They are almost certainly insurmountable. The stage a billion years ago was empty. It was a world of microbes, patiently waiting for the long, slow fuse of evolution to burn. It seems almost certainly that we are the first. And yet, is that the most important takeaway from this journey? The power of this question, the Silurian hypothesis, was never really about finding aliens in our own past. Its true power is in what it forces us to confront about ourselves right now. It's a tool, a thought experiment of profound and unsettling implications. It cracks open the provincialism of our human-scaled thinking, our belief in our own permanence. It forces us to look in the most terrifying mirror imaginable, the mirror of deep time. Because this entire investigation into a phantom civilization has been an elaborate forensic study of our own. The chemical fingerprint we assembled, the carbon spike, the technofossils, the nuclear echo, the dead zones, it was a blueprint of the Anthropocene. It's the signature we are actively, and at an accelerating pace, imprinting onto the planet's geology. This hypothesis holds a mirror up to our world and forces us to ask a devastatingly simple question. If we are a civilization, what does a civilization's end look like from a billion years in the future? So let's look. Let's stand in that imaginary future and look back at our present. Look back at our cities of concrete and steel, our satellites in orbit, our sprawling networks of roads. Now let the clock run. 100 million years. 500 million. A billion. The relentless cycle of plate tectonics grinds our continents, subducting our coastlines and melting them into magma. The skyscrapers, the monuments, the libraries. They are pulverized by ice ages, eroded into nameless sand, and buried under miles of new rock. Our very bones turn to dust. When all of it is gone, what is left of us? The answer is not a single ruin. The answer is the exact same set of clues we were hunting for. We won't be a city. We will be a layer. A cryptic, thin band in a future geologist's core sample. We will be a sudden, violent spike in the carbon isotopes. We will be a strange deposit of polymerized hydrocarbons, our plastics. We will be a faint, anomalous trace of man-made elements that simply shouldn't be there. We will be the unexplained, anoxic event in the rock, a testament to the time our oceans suffocated. We are, in effect, becoming the ghosts we were searching for. We are a civilization in the process of laying down our own chemical tombstone. The power of this idea is that it transforms us from the explorers into the explored. It recasts our present moment as a geological event, a brief, violent, and perhaps tragic anomaly in the planet's 4.5 billion-year history. We are the puzzle. We are the civilization that a future intelligence, perhaps non-human, perhaps a billion years from now, might one day hunt for. Can you imagine them? That future intelligence drilling a core sample, finding our strange, thin layer. They would puzzle over it. They would see the chemical signature of our global combustion, the sudden extinction in the fossils above it, the weird molecules of our waste. They would write papers just as we do. They would propose natural causes. A supervolcano, a tectonic event. And maybe one of them, a bold or heretical thinker, would propose a truly wild idea. What if, for a brief, shining, and catastrophic moment, there was an industrial civilization? And that is our true place in the universe. It's the ultimate shift in perspective. The real question this hypothesis poses is not, were they here? It is, what story will we leave behind? When all our songs are silenced, all our art is dust, and all our accomplishments are meaningless sand, what will our layer say about us? Will it be a warning? A tragedy? Or just another cryptic scar in the rock? A mystery for a future world to solve? A faint chemical echo of the time we called the present?